The topic of radiation is certainly not a new one for a school physics course. This film, however, will show a series of very simple experiments which it is suggested you might like to get your own pupils to try for themselves. We have already found how effective these experiments are, how the pupils come to a much better understanding when they do these experiments, rather than merely being shown a demonstration. The response of the pupil's own skin, the back of the hand, the cheek, is used to detect the radiation. For the source of radiation, a glowing electric heating element, as used in a bowl fire, is admirable. It is especially good if you take the precaution of shortening it by 10 to 20% before using. Although not as good, you can use the radiant from an older type gas burner. It should be suspended above a Bunsen burner flame. Margaret, would you take these away, please? Thank you. To limit the radiation, we use an asbestos sheet, which has had a hole about the size of a penny cut in it. You will notice that the reverse side is bonded with aluminium to help reflect back unwanted radiation. Of course, we can see the glow from the heater through the hole. And your cheek placed near the hole also responds to the radiation. Now ask your pupils to find out what happens when a book is held in the way. Is there any difference in response when the book is brought nearer the cheek or nearer the source? Now try it with a sheet of glass. Does this cut out all of the radiation? Try it a bit nearer, and nearer still. Then try 2 sheets of glass. Those are all questions for the pupils to answer themselves after doing the experiments. So the glowing heater is clearly giving out light. It is also giving out a radiation to which the cheek responds and which to some extent can pass through glass. Is there any difference in the radiation coming from different surfaces? Let's investigate. Here is a thick sheet of copper. One side is polished. The other side is already black, but I'm going to coat it with a mixture of carbon black and alcohol to provide a thoroughly dulled black surface. We'll leave it to dry and continue with this one, which was prepared earlier. Make sure the polished surface is down and heat strongly over 3 burner flames. After a few minutes, turn off the gas and turn the plate into a vertical plane. I'm going to ask Margaret to come and help me again. Margaret, will you hold your cheek close to the polished side and to the black side?
Oh, it's hotter this side.
Most people seem to say it's hotter. Don't allow that. Correct it to it feels hotter. This experiment seems rather more convincing than the usual one with Leslie's cube. Now let's extend our experience by returning to the electric heater. Margaret, will you hold your hand in front of the hole and see how long you can keep it there? That didn't take long. Now I'm going to coat the back of your hand with aluminium foil. Clench your fist and lick the back of your hand. It has to be quite wet. Fine. On goes the wafer-thin foil with a puff to make it stick. Now relax slightly and try that. It seems as though you can hold it there for as long as you like. That could mean that the radiation is stopped by the aluminium foil, just like the sheets of glass. Let's now coat your hand with black paint, using the same carbon and alcohol mixture I used before. Leave it to dry and try again. That was only 4 seconds compared with about 40 without the black coating. That should make it quite clear that the radiation is reflected back by the shining surface, but absorbed by the black one. Now comes the problem of cleaning Margaret's hand. Running water from a tap will take care of it, but above all, no rubbing. An additional experiment you may like to try will show that radiation can be reflected. Here are 2 electric bowl fires, from one of which I have removed the heating element. This element has been shortened by 25% and is running at 270 volts. Explore with the back of the hand. That's the hot spot at the focus of the bowl. You can add to the fun by putting a match there. These experiments have been very simple, but they provide, for the younger pupils who actually do them, an effective introduction to the properties of radiation.